robot control using Bluetooth and animation. This is based on the demonstration which we will be presenting tomorrow for junior exhibition for Robosses. So, as children, we face a little difficulty in building robots, not because we did not know C, but because we weren't experts yet. But programming thrilled us, so we began looking for some way in which we could overcome this problem. Another thing we noticed was that there was a gap between what we had in mind and what the robot ended up doing. So this was very frustrating for us. Okay, so sometimes when we started testing the robot, we noticed that the robot didn't turn properly. So this could be because of surface resistance, or maybe we weren't using the correct type of motor. But we wanted a platform where we could test this several times so that we didn't burn our pocket money on new robot parts, like without testing it first. Another thing was that mobiles are becoming ubiquitous nowadays. I mean, who doesn't have a smartphone nowadays? So we figured that it would be easier for children to control robots using a portable handheld device like a smartphone. It offers very good maneuverability, much better than any wired interface. Okay, so let's get on to the introduction. That's our robot there, Roger. He's a very simple robot. Very simple robot parts. We have 2 wheels, 2 DC motors controlling the wheels. That's a robot controller board, and there's a Bluetooth UART right on top. And the robot controller board has an Atmega 16 processor. So any robot can work in a specified environment. Like you can have a grassy environment, you can have a desert, or even underwater. Another thing is you need to process the information in the robot. For example, I can issue a command to take user inputs. Like the user input could be something simple, like move forward or turn right, or something a little more complicated, like dealing with hazardous material, line following, obstacle avoidance, something like that. So this takes us to the third point, dissemination of commands to the various parts of the robot. I'll give you an example here. So if I tell the robot to move forward, then both the wheels of the robot have to move forward. If I tell it to move right, I mean turn right, the left wheel has to move forward and the right wheel has to move backwards. Next slide. Okay, so we've looked at the existing work in this area. You have sensor-based robot control. Here, it takes the inputs from the sensor and processes the information. In this category, you have line following and obstacle avoidance. A lot of work has been done in this area. Apart from that, you have integration using pre-programmed and pre-assembled components with accompanying software. And a very good example of this is Lego. So what you see here is the Lego graphical user interface. It looks very attractive, and it's kind of easy to program too. So our solution comprises of 3 components. Firstly, you have an animation-based mechanism to specify the actions of the robot, that is to give actions to the robot. And we're using Alice 3.1, some of you may be familiar with it. You have the sequence analyzer software. What we did is we wrote a C program to parse the XML file. You see, Alice saves its animation strips in an XML format. So we wrote a C program to parse the XML file and to convert it to Java. So that's the sequence analyzer software. It translates the animated steps to granular tasks. The next thing is the distribution of these granular tasks. So what this means is you need the Android mobile and this Java program, which we have from the XML file, that runs on the Android mobile. So using the Android mobile, you control the robot. And we control it using the Bluetooth wireless interface. So this is a rough diagram describing how our project is. So over here you have the Alice 3.1 screenshot. So what you have here is just a rough diagram of the environment and the objects in it. Here you have the whole of the code. So this is the procedures. The procedures are a set of actions which I am giving to the person on screen, the avatar, I'd like to call it. So the next thing is the sequence analyzer. The sequence analyzer is that C program which I was telling you about. So the C program converts the animated steps into Java files which can be run on the Android mobile. So the next thing is the Android mobile. So when you run the program, the Java file on the Android mobile, it sends messages to the robot using Bluetooth. And when the program is run on the robot, it does the specified action, the one that's specified here. So whatever the avatar does on screen, the robot does physically on the ground. Next slide, please. Yeah. So we propose three main characteristics to control the robot. The first thing is the animation program, that is Alice 3.1. This is used to represent an avatar of the robot. An avatar is a virtual representation of the robot. So the robot does anything that the avatar does in the end. The next thing is Bluetooth. Bluetooth is the wireless interface that is used to connect the Android mobile to the robot. It sends messages through Bluetooth. The third thing is the Android program. The Android program on the mobile, it sends messages to the robot using Bluetooth. And the robot does whatever the avatar does on screen. It mimics it perfectly. Next slide, please. So let's get down to the implementation. I'm going to break it down into three parts. The first part is animation. So in the first part, we're using Alice 3.1 to make virtual environments and avatars. So you can edit this completely. You can have it exactly as you want in your mind. So that's what I said. You can just translate it from memory to computer. So this, once you specify everything, you can give them tasks. So you can give the avatars tasks to do on the laptop, and Alice 3.1 will make an animation strip. When you run it, then the avatar will do all the tasks given in the procedures lists in order on screen. So this is just some screenshots of Alice to explain how it works. Over here, you have Roger. Roger is our robot's avatar, and you have him in a grassy environment. You can edit this however you like. He looks like he's back from a hairdresser. So you can edit his clothes, everything. I'm not sure he likes it. You can edit his environment. You can put him in a desert. He can go scuba diving. I'm sure he'll like that. So over here is Alice's ability to specify granular actions. Now this is important. I can tell Roger to turn right or move forward. And I can specify the direction he has to move, like right or left. And I can also specify how much he has to move. So I can say he needs to move 2 feet, or I can say he needs to move half a foot. I can say that. And the next thing is, I said that you can specify the environment. Alice gives you a list of things that are in the environment over there. So part 2 concerns the C program which we have written. So as I said before, Alice 3.1 stores its animation strips in XML format. And our C program parses this XML file to get a Java file. I'll be explaining this more in detail in the next slide. So you can just you can get the avatar here. You can specify the avatar. That is, if I want all the tasks for Roger, I can just say I need the tasks for Roger, and it will give me all the tasks. It will go through the XML file and extract the actions for Roger. So this is a flowchart explaining exactly how our XML parser works. Here, the first thing we do is we identify the avatar for the robot. As I said, you can have Roger, or you can have any avatar of your choice. After we get the avatar, you can extract the corresponding node key. So every every avatar has a node key. So you extract the corresponding node key. You extract the node key for Roger. Once you've done that, you can get the whole of the action sequence from the XML file. You can have, so if I tell Roger to turn right, and then move forward, it'll have all that in the action sequence. Once you get the action sequence for this node key, you can go directly and generate the Android code. And then you can directly run it in the mobile. Let's go deeper into the details of the prototype. So this concerns an Android program running on the mobile, which communicates to the robot using Bluetooth and runs the program on the robot. This is a list of the components of our robot, but I explained that earlier. So let's go to the next slide. Okay, this is the Quick C program. This is the thing that runs on the robot, which essentially makes the robot move. And this is the thing that receives the UART commands from the mobile and controls the robot. Okay, this is a diagram showing the results of our project. So as you can see here, there's Roger in his virtual environment. He moves forward and right. And Roger in his physical environment, that is right here, he moves forward and right too. And you should note that he mimics Roger, he mimics his avatar perfectly. See, it's perfect. Next slide. Okay, my friend Isha will be explaining the advantages and concluding.
So, as part of the earlier mentioned problems that we faced, we overcame this with with the advantages of our approach, which includes that using animation makes robot programming far more fun and far easier for first-time robot enthusiasts like us. And we used a wireless interface, which of course gave us far more maneuverability, and the open source prototype and an open format as opposed to the proprietary-based format for representing the granular tasks of the animation software made it easier. So we can iteratively review and tune the robot's actions without actually investing and spending our money. So depending on the physical environment in which our robot is, say the robot has to move underwater, then the robot would need a streamlined body. If the robot had to move over an uneven surface, it would need a belt instead of wheels. And our intention in this project is to broaden the horizon of robot programming to children like us, who are introduced to animation softwares and are interested in robotics. So we overcame our hurdles through three mechanisms: animation, a wireless interface to control the robot, and an Android mobile to host the controller. So we intend to extend our XML parser to include more avatars who can do more actions at the same time. And we want to make Roger more attractive, the robot. We want to make him more attractive and more complex. So if anyone has any platforms for this, please talk to us. And yeah, and if anyone would like to partner with us, you could talk to us today or tomorrow at our demo at the Junior Exhibition of RoboFest. So feel free to email us at vishnubright@gmail.com or visit our Google Plus page, or you could just search for the Robosses. Thank you. If anyone has any questions, ask us now.
Do visit our demo tomorrow at Junior Exhibition.
So I have a question. How long did it take to complete this project? It seems like you already have a prototype. That's something you'll be demonstrating tomorrow.
Yeah.
How many months or
Weeks
did it
about
take?
a month, right?
About 2
2 or 3
months.
weeks.
About a month.
Yeah, about a month.
Wow, that fast.
Who did the programming?
Yeah.
We did.
Yeah.
We did it.
All of you? Or-
Yeah.
We did it together.
Okay.
Thank you. Thank you.
Great. Yeah. We're excited to see your demonstration tomorrow. Thank you.